let us start this lecture with a thought process. Scientists believe in things, not in person. This is Madam Marie Curie, you might be knowing. She is a very great scientist. And let us recall what we learnt in the last lecture. We basically looked at series reactions, parallel reactions and reverse reaction, how to handle basically, and what are its ramifications, because it is very important to handle the multi-step chemistry, particularly the elementary reactions, right. And today we will be talking about basically the chain reactions, because it is which is very important. Chemical reaction not only takes place in series and parallel, it will be in the chain, right. And chain reaction is very important, and you might be knowing that chain reaction also not only occurs in chemical reaction, it also occurs in nuclear, right, reaction. So, and it also occurs in our day to day life, right. We can say, oh, there is a chain reaction, that means suddenly something is happening, right. So, we will have to be aware about that. In reality, combustion process involves several reactions, and whatever we see that stoichiometric chemical reactions, whatever we consider, we always happy with the stoichiometry, right. But that need not to occur in nature as such, because there is a lot of things which will be going on. So, if you look at we will be now classifying these reactions into 4 categories. Those are basically chain initiating reactions, chain branching reaction, chain carrying reaction and chain terminating, right. So, we will have to see who initiates the things, because initiator is very very important. Like in our spiritual fiefdom, the guru is known as the initiator, right. And even in teaching also, that is, this is the basically initiator, is a student has to learn, like, okay. So, therefore initiation is very important. And similarly branching, it will be branch into something and it will be carrying forward. The meaning is very obvious, like means you will be carrying forwards, and it will be also terminating, right. Now question arises, how you will define these things, how I will identify whether it is a chain initiating or chain branching or chain reacting. For example, if I consider, right, this is, let us say, if I say this is H2 plus O2 is going to H plus H plus O2, right. Are you getting? Now, what kind of reaction it is? Let me write down another reaction. O2M is getting into O plus M. M is basically third body reactions, and I can write down another reaction. O2 plus H is getting into OH plus O, right. Now, in this reaction, which is chain initiating, which is chain terminating, which is chain carrying, or which is chain branching, right. Please think about from this. Let us say, let me write down further, right, H plus O2 plus M, HO2 plus M, OH plus H plus M getting into S2O plus M. Now, if you look at, if I say this is reaction 1, this is 2, 3, 4, this is 5, right, or I am writing for basically to say that is a reaction, right. Now, if you look at the first reaction, what you call? It is initiating. Why? Because the stable species are there in the reactant. These are stable species. These two are stable species. And then the radicals are being formed, right? But if you look at this O2 and M, O plus O is the same thing. O2 is a stable species. Of course, M you do not know. M is a third body, like it is not participating, but it is, its presence is required, right? You can't call it as a catalyst reaction, okay? But however, this presence is required, like let us say there is an old man in the house, but his presence, he won't do anything, but his presence is required because he will give inspiration for you people to do work, right? Like your grandfather or grandfather, right? You won't be doing anything. So similarly, third body is like that, okay? So this is again chain initiating, but the reaction 3 or the third reaction, O2 plus H going to OH plus O. What is this reaction? Is a branching or carrying? It will be branching. How I will decide? How I will decide? If the ratio of number of free radicals in the product to the reactant, that of the reactant, then greater than 1, it is chain branching, right? For example, in this case, in the reaction 3, these are 2, right? And in this side radical is 1, so therefore it is ratio of radicals, right, between the product and the reactant, right? I can say the ratio is greater than 1. So therefore it is a chain branching reaction. Therefore this is a chain branching reaction, right? And similarly you can say chain carrying reaction when this ratio is equal to 1. This is equal to 1. That means if you look at this reaction, reaction 4, this is a radical, right, HO2, and this side the radical is H. That means 1 1, right? Reactant, the product side radical 1 and reactant side radical 1, therefore ratio is 1. So this ratio I can say, okay, ratio is equal to 1. And in chain termination, what it would be? Stable species will be, that is 1, but if you consider from the radical point of view, it will be always less than 1, right? It will be ratio is less than 1, therefore that is known as basically terminating. And chain initiation is will be other way around, right? Always the reactant side will be stable species and product there will be some radicals, right? It will be greater than 1 also. It is similar to chain branching, but keep in mind that in the reactant side always stable species will be there, right? It will be 0, radical will be 0 in the stable species. In chain branching, radical will be there in the reactant as well in the product. That means it will be there in the reactant and product, okay. Now that is very clear, you can identify which is chain branching, chain initiating, chain carrying and chain terminating reactions by this process or the procedure. Now let us look at this chain branching, and if it is more radicals are formed in the product than the reactant, then it may lead to explosion. But what do you mean by explosion? Any idea? Any idea what is the meaning of the meaning of explosion? You might have heard like uncontrolled combustion, you were saying. For example, if I say there is a pressure cooker which is bursted out, right, there is no reaction taking place, yes or no? Is it reaction taking place? Pressure cooker I will heat, give lot of heat, and then it will burst out, or I will take a balloon, and give a lot of these things. There is no chemical reaction taking place, okay, but it will burst out. That means there will be sudden pressure, release of energy, which we can define that way. That is a little better one, right? Here what we are doing, right? This is basically we are saying, look, chemical reaction is taking place, right? But in nuclear reaction, nuclear explosion, right? Because there will be nuclear reaction will be going on, but basic is idea is that there will be burst of energy which will be causing some kind of a pressure change sudden and temperatures and other things. So therefore we can say that in our case it is the very rapid combustion of fuel and oxidizer that takes place, leading to a violent release of energy. That is very important. Violent energy of release, right, resulting high pressure and temperature change, right. This will be, of course, this is caused due to the high pressure and temperature in a very close container, right. So therefore explosion can be divided in two categories. One is thermal explosion, right. Other is chain branching explosion, or you can say chemical explosion, you can say in our case. Of course, there will be nuclear explosion, right. So thermal explosion means basically heat liberated due to initial phase of accumulated temperature, or you are supplying the heat, right. Heat is being supplied and the loss is minimized, or loss is not there, or loss is less as compared to the heat input to the a container, closed container particularly. Explosion won't occur, it is open, are you getting? Unless pressure builds up and other things, it won't burst it out, right. So that is basically occurring, this thermal explosion occurring due to insufficient heat loss. That means more energy is being pumped into, right. The balance, if you look at more energy is getting in. Chain branching explosion, in this case what will be happening? This is due to basically accumulation of chain carrying radicals. For example, in chemical reaction H, OH, these are all very what you call problematic radicals. I can't say problematic radicals, problematic radical from the explosion point of view. For the chemical reaction, without that you can't have a chemical reaction, right. So those are good, but if it is misused, then that will be creating a problem of explosion, and this is being accumulated. That means whatever being generated is not being consumed, right. It's like your the rich people became going astray, they are accumulating so much of money, right, or so much of power being accumulated, it will cause the explosion. So therefore that is anything, accumulation is a bad thing. That is why our scripture says you always donate, keep the balance right. So now let us consider a case in which, let us say, stoichiometric hydrogen oxygen mixture is there, right, and I am keeping this, it's like a bomb, you can say, is a closed vessel, and supplying the hydrogen and oxygen. After that I am closing it, right, these are all closed, right, that means is a close, right, is a closed bomb kind of valve control, volume is remaining constant, I can close this, okay. And then I am increasing this temperature. Temperature bath means where I can control the temperature, right. So that temperature bath I can goes on increasing. Let us say this T of the temperature bath, then there will be heat transfer, right, and it will be getting into from here to that, the heat will be getting into, right. Now what will happen? There will be if it is at ambient temperature, if T is equal to 298 Kelvin, start with what will happening? there will be no reactions, like all the forward reaction will be same as the backward reaction, almost it will be, nothing will be happening. But if I go on increasing the temperature further, then some chemical reaction will start and it will be basically stable, then it will be metastable kind of condition. Earlier, it became unstable, right? And then reaction will be taking place. If reaction takes place, heat being released, right? If it is heat released, what will happen? If the constant volume, pressure will go up, and again there will be some accumulation of thing will be occurring. Let us look at what is happening. If I say that hydrogen will be reacting with a third body, right, and getting into this H and H radicals, this is basically what kind of reaction this is? First one, what is the reaction here? Chain initiation, right? Reaction. Now this is endothermic in nature. See, unless you give heat, it will not occur, okay? Are you getting? But there is another reaction. This is again hydrogen oxygen is reacting with third body, it will going to S2O2, right, M, and again this is the endothermic. Keep in mind that this is, if you look at, this is the higher, right, as compared to this reaction, because these two can go parallelly, like hydrogen can decompose or hydrogen get into S2O2, and one is, and this will be the first reaction. If you look at this one, right, will be occurring at a much higher temperature as compared to second one, isn't it? Because the energy requirement for the 230, it will be, heat has to be supplied for this reaction take place, right. So now if it is occurring, there will be certain temperature. If you look at, you will go to the self ignition temperature. If you go on increasing, right, because I am not igniting here, then the reaction will start, which will be vigorous, right. The pressure will increase. If pressure will increase, what will happen? Explosion will occur or not, right. Let us say, as I told, to begin with, the stoichiometric mixture is taken, is kept a container, stoichiometric mixture at a certain pressure, right, and you will go on increasing temperature in that container by the what you call your like thermal bath, right. By that I can control the temperature, and let us say it is increased beyond 733 Kelvin, where the reaction will start, and then it may lead to explosion, right. So the rapid chemical reactions will be take place leading to the explosion, let us say at certain pressure, right, at certain pressure, let us say PB, right, at pressure PB it is occurring, right. Now I will reduce the pressure, right, okay. What will happen? Will it like explosion will occur or not, right? Actually explosion will occur even if you are reducing, right. But generally notion is that if pressure is there, you will release, no, because this is a chemical reaction, you do not know what is happening, and if tank pressure is pressurized beyond certain values, right, then again explosion may occur, right. Now in between some range, explosion won't be occurring, even though temperature is higher than its self ignition temperature, and the pressure is moderate, right. So if you look at that, if you conduct this experiment, and you will find a curve like this, right. If you look at, suppose I am here, right, at PV, and PV, that means PA to PB, this explosion is occurring, this is the range where explosion will be occurring. But now if I will increase the pressure, right, okay, what will happen? There will be no explosion even though I am increasing, but if I reduce the pressure, explosion will be occurring, right, and there is no explosion. But if I will go beyond, in this region, but if I will go beyond this, right, then explosion for the same temperature. I am talking about at the same temperature, keep in mind, because there are two variable I cannot change. Just to explain this thing I am saying, I am conducting expansion such that temperature will be remaining same, only pressure will be changing. So, pressure beyond that there will be explosion, because this region also explosion is occurring, right. Now, it is quite interesting, this curve is basically S shape, you can say inverted S shape, right. S we write other way around, this is inverted S shape curve, and this is valid for what is that, hydrogen oxygen system, right, or you can say N2 system, or I can say this is hydrogen oxygen system, right. And similar curves you can get for CO and SO and other things. I will not be discussing, but you can look at maybe Kuo book or some other combustion book you may find, right, not in my book. Now, question arises why it is happening. We will have to look at it qualitatively, looking at some reactions, right. And there are regimes, 3 regimes are there. This is the first limit, right, regime, and this is your second limit, right. This is your second limit, and this is your third limit, beyond which explosion will be occurring. And let us consider these reactions. See, you can take more reactions as well, because it is not that all this only this much reaction will be occurring. There will be several reactions I have shown, right. I have taken only just to explain certain points, right. Let us look at what is happening in this reaction. I have already explained that in the reaction 1, right, at high temperature it will be occurring, because this is endothermic in nature, right, and as compared to the reaction 2, these are all chain initiating reactions, right. But at low temperature and high pressure, S2 is dissociated by R2, this reaction 2, right. And for reaction 1 and reaction 3 to 5, except reaction 2, if you look at reaction rate is proportional to P square. Why? Because bimolecular reactions, right. These are bimolecular reactions, right, yes or no. So, therefore, the second order reaction is there, therefore, it is required to this. But whereas reaction 2, this is the reaction, right, this reaction, and reaction 6, these reactions, right. For that, this is reaction rate is proportional to power to the pressure of 3, pressure cube. That means, it will be more, the reaction 2 and reaction 6 will be more pressure dependent as compared to the reaction 1 and 3 to 5. These are all, if you look at chain branching, if you look at reaction 3 is chain branching, reaction 4 what you call, reaction 4 is what? This is chain carrying, this is your chain carrying, is not it, and this is your chain branching. And this is again what you call chain carrying, right, this is also chain carrying. And these reaction, if you look at the reaction 7 to 10, these are all terminating, right, because 2HO2 going to S2 and the stable space is in oxygen, it is getting into wall and then converting. And similarly here, and H of course can bumped into wall and reduce energy is will be OH also. So, and keep in mind that for reaction 1 and reaction 3 to 6 involves what is that, H, because these are all radical, H, O, right, OH, right, OH and HO2, these are all radicals which are required to convert the hydrogen into water, right. And of course, 9 and 10 I have already told, these are basically OH and OH are lost getting into or colliding with the wall of the container, right. Because this will be having lot of energy level, it will be moving. So, if you look at the low pressure, what is happening if HO2 is being formed, right, by the reaction R6, this reaction, right, HO is formed, and if it is happening at low pressure, this is a very, you know, what you call you can't say inert, but it is not much reactive as compared to H and OH, okay, HO2, although it is a radical. What will happen? It will go and hit to the wall and lose its energy, then as a result, you know, it will not lead to the explosion. But whereas a high pressure, what will happen? It will be getting and bumping into others, and then some radicals are formed, so that it will be leading to explosion. So, therefore, at between PA and PV, radical formation by R1 to R6, right, okay, are much higher, the more radicals are formed as compared to the reaction R7 and R10. R7 and 10 is what? This is radical being terminated, right, these are terminated, means consumed, right, without much branching occurring. So, therefore, this P, right, radical formation are higher, so therefore, there will be explosion in this region, right, PA and PB. But in P, B and C, R6 is more predominant, right, this one, and more HO2 will be formed, and which are not that reactive, and if the pressure is moderate, you know, like in between, it is not very high, right, you can consider this to be relatively low, then there will be no explosion, right, provided in this region between PV and PC, no explosion, right. So, and if you go beyond PC values, beyond this pressure, this is the higher values, then what will happen? HO2 and S2 is going to the S2O2, and this will be right, and H is radical is one formed, and S2O2 is going to OH and OS. So, more radicals are being formed, and that will be because HO2, which was not acting in this region between PC and PV, but when pressure increases, that became more active, because they are colliding with the hydrogen, colliding and then giving to the more radicals, and these radicals are formed, the more pull, that means more explosion will be occurring. Are you getting this point? So, therefore, we need to, I mean, like, you know, look at the importance of the reactions in certain pressure range, which is more important, and that will lead to the explosion, and certain reactions are not important. Particularly, this is being explained, you know, in terms of chain branching reactions, right, because if it is branched further, then what will happen? Explosion. If it is branch being stopped, it is not going into, then it will be what you call explosion won't occur. So, if you look at, if you know these things, you can avoid the explosions to occur also, you can devise something, and that is being done routinely in our case. Suppose there is a problem, so what will happen? You clamp, you know, 144, suppose there is some riot, because they will be spreading, instead of you 44 and then control it. Similar way, you can also control the explosion, provided you know which radicals and which is the what is the pressure range, what will be, you can, you know, thwart the occurrence of the explosion. So, with this I will stop over. We will be discussing the next lecture about basically how to handle elementary reactions by some certain techniques we will be developing to minimize the number of reactions, and also how to handle, right. Thank you very much.